So example number 2, we're looking for moles. We were given atoms of silver to start with. So if we take a look back here, guys, where are we starting on our roadmap? What's that? On the right, right? Because we have atoms, okay, so we're right here. So we're trying to get to what unit? Moles, in the middle. So guys, just follow your arrow. What are we going to have to do? Well, we're essentially dividing. Notice, this is the number we're going to use when we go from atoms to moles. So set up your T-chart. What goes below the first one always? A 1 is a placeholder. Atoms has to go on the bottom, which is going to help me to divide, right? If it's on the bottom of a fraction, I'm dividing. Moles will go on the top. Okay. Atoms will cancel out. Now, if you remember yesterday, this is going to be the hard part for people where they get their numbers mixed up, guys. Think about it. Okay? In a mole, how much does a mole equal? Well, 6.02, right? Absolutely. So that's going to go with your atoms. Moles should always be smaller. If you put it up here like this, okay, and this is not the correct way, if you did that, guys, you would get something times 10 to like the 48th power. That's absolutely absurd to have that in big a number of moles. It can't happen. So if you see that that happens, if you get something times 10 to the 48th, you know you did something wrong. Okay? You need to go back and flip that conversion factor, all right, like we had here. So Avogadro's number is going to be on the bottom. 1 mole is going to be on the top. The other way, if you can remember this, whenever you have moles in a conversion factor that you're using, maybe not what you started out with or what you end up with, but when you have it in a conversion factor relating to another unit, the number 1 always goes in moles. So all we have to do is do the math. How do we plug this into our calculator? Our final answer when we do the math is smaller than what we started with. When we're going to moles, guys, moles are always going to be smaller than what we start with, okay, what we're converting from. It should always be the smallest piece within it, okay? So, let's do example 3 together, and then you're going to do a couple examples by yourselves. What's different here, guys, about example 3? Mass. What's the unit that's associated with mass? Okay, so we're looking for grams, and what are we given? Oh, we're given atoms. So I'm going to write down what I have, 1.20 times 10 to the 8th atoms of what? Copper. Put that with it. We'll set up a T-chart, put a 1 below my first one. So I'm looking for grams in the N. Yeah, Michaela said it. So if we look here, guys, we're starting on the right like we did with our last problem, but to get to mass, there's no direct one-step link to go from particles all the way over here to mass. So we have to go through moles first, then to mass. Take it one step at a time. Follow your units. Do I want to stay with atoms in this problem? No. So where does it have to go to cancel out? On the bottom. Atoms will go back to moles. That's our link between the two. Cross atoms of copper out because you've already used it. Now, before you even worry about other fractions here or other parts of your conversion factors, get your numbers right. When I have mole and something else in the same fraction, which one gets the number 1? Mole will always get it in a conversion factor. And what's the number, guys, that's related? How many atoms are related to a mole? Yeah, 6.02. Okay. Now, is that where I want to stop in this problem? No, so I need another one. So just add another T to my chart. What unit's going to go on the bottom? Moles, because we want to cancel it out. Moles of copper. And this is the step, guys, where it's important to keep copper with your unit all along. Because now you've got to figure out grams. Where are we going to get the grams of copper? Periodic table. So this is why if you don't write copper down, okay, with this problem, you could look back at it. But in the future, guys, we will get to problems where you're going to be going from one substance to a different substance. So you'll have 2 gram units in your T-chart. You got to keep your substance with it. I know it's an extra 5 seconds of writing, and we're like, oh, I don't want to write anything down. I'm telling you, it's going to pay dividends down the road. You got to trust me on that. What's the molar mass of copper from your periodic table? Okay, guys, with these masses, you're probably okay to round it, 2 decimal places. All right, it'll be plenty okay, but if you want to keep them all out, that's totally fine. All right, so now we got to do the math. Multiply all your tops together and then divide by your bottoms. So, the more you practice, guys, the easier this is going to get. You've got to commit to that practice. If you don't, you're going to struggle all year long. So the next piece, guys, that we're going to talk about is gram formula mass or molecular mass or molar mass to the next step, okay? We've done it already for a single element. Are we always going to have just single elements in this class? No, we're going to have what are called what? Compounds. Now, you guys know what compounds are. You've seen them before. All you have to do to get the mass of a compound, guys, what does sum mean? Add. You're just going to add up all the individual masses of your elements. It's that simple. Now, the way that I show it, I highly encourage you guys to show the work like I'm going to show you, because it's going to make, when we do percent composition next week, it's going to make that work already done for you. Okay? So if you trust me on it, it's going to seem like more writing now, but if you trust me, it's going to make light of the work we're going to do next week. It's going to make it quicker. So sodium chloride. I didn't give you the formula here. I know we haven't done naming yet. That comes in a month or so. But you guys should know sodium chloride's formula. It's common. What's the formula for sodium chloride? NaCl. You guys have seen that one already, so I didn't give it to you. For now, I will give you guys both the name and the formula. But later on, once we do naming, you will have to go from a name to a formula, or from a formula to a name. That comes later on. And that takes lots of practice, and it's practice. That's the only way you can master it. Anyway, that comes later. So here we go. What I'm going to do is I'm going to isolate each individual element, and I'm going to kind of write them down. The next step, guys, I'm going to do is see how many elements I have of each. Where would we look in a formula to see how many elements, how many atoms of each element we have? Periodic table comes in later. Good guess, though. The lower right, okay? Because if I said H2O, you guys would be able to tell me how many hydrogens do I have? How many oxygens do I have? All right, so you've seen this before. You've done it. The lower right corner, guys, is what it is. If there's no number written there, it's assumed to be what? 1. So we have one sodium atom. We have one chlorine atom. Excuse me. Once we figure out how many we have, guys, we're going to multiply each of those by their molar masses. What's the molar mass for sodium when you look on your periodic table?
2, 1, 2, 3, 4, 5, 8, 9, 8.
Good save there, by the way. 22 point what?
9, 8, 9, 7.
All right, that's good enough. 3 or 4 decimals is more than enough to go to. That's easy math. All right, it's going to be the same thing. 22.9887. And that's according to Michaela. All right. Again, that's Michaela's fault.
I said it right.
989. We'll just call it that. Okay, we don't need to go further than that. Okay, chlorine's mass is...
35.453.
That's easy math as well. So now, guys, the last thing we have to do is just add up all the pieces. Okay, it's the sum of all the masses. So we've isolated, we figured out what's the part that sodium brings, what's the mass that chlorine brings to the compound. Now we're going to add them all up. Let's see, that's a 2, carry the 1, that's a 4, carry the 1, 0, 4, that's another 4, carry the 1. What's that, like 8? Look at that, doing some math there, old school style. Like, is that like 2nd grade these days? I don't know when you learn that. It probably is. Now, what do you think our unit's going to be, guys, for molar mass? That term tells you what it is. It's grams, but it's not just grams. It's grams per mole, guys. That's what it is by definition. Okay? Molar mass, that term, think about it. It's got 2 words in it, molar and mass. So it's the mass of 1 mole of a substance. Okay? So this is the unit that you will need to have. And yes, this is a double unit. Why do you think we've practiced double unit conversions? Oh boy, look at that. See where it's all coming back. Okay? Don't worry about it right now. Grams per mole, guys, is what you need to remember. Okay? Because it's actually going to be easier than you're thinking. Is that difficult? No, you're just adding things up. Like I said, one of the easiest things we do this year. Let's take a look at example number 2. What's different now about example 2 versus example 1? It's got more atoms. What else does it have? It's got parentheses, okay? So let's just break it down step by step. What was the first thing we did here before we started worrying about number of atoms? Separate all your elements out. So just write them down. This is calcium nitrate. I've got calcium, I've got nitrogen, and I've got oxygen. Okay? Now let's go back and start to figure out how many atoms I have of each element. How many calcium atoms do I have?
1.
I've got 1. Now, how many nitrogen atoms do you think I have? Sarah, you're holding up 2. Why do you say 2?
Because you put the 2, you kind of said you put the 2.
Yes, you're going to distribute like you would in math, guys. What this is saying is that I have 2 nitrates that are there. So this is like calcium, and then I've got 1 nitrate together, and I've got another one. So when we come back to do bonding, we will learn more about this. We do naming, what these special things are called. You want to keep track of it, guys, that you're going to distribute into your other subscripts. So you're going to multiply. I've got 2 nitrogens. Think about it. When I drew it over here, add all the oxygens up. How many oxygens do I actually have? I've got 6, okay? Now we're just going to multiply each of those elements by their individual element masses. Mass of calcium, if I remember correctly, it's like 40.08. When you've done it this many times, it's just repetitive. Nitrogen's like 14. What is it? 14.00. All right, so 14.007. All right. Oxygen should be exactly 16, but I think yours is like 15.9997 or something like that. 9. So close. Okay, do that math. 28.014. I can't do that one in my head. So we do 6 times. Tell me what oxygen brings to the table. Thank you. 95.94. Then just add them all up. I'm going to wait for you guys to do it with the calculator instead of trying to do it, carrying the ones and stuff. What's our molar mass for calcium nitrate? 100 what? 164.0698. Is it just grams? Per mole. Okay? Per mole. But, there you go. Molar mass, guys, don't make it harder than it needs to be. You're looking at each piece, and you're adding them all up. Okay? I want you guys to try sodium phosphate. Be the last example we'll do, and then I'll give you your homework.